Alright, 8th graders, this is your chance to graduate from tiles early. I'm going to give you an example of how to solve the modeling problems, and I'm going to show you step by step exactly how I want to see them solved. Then I'm going to give you 3 problems that you can do on your own. If you bring to class tomorrow those 3 problems solved exactly the way I solved this problem, then I'll let you graduate from tiles early. Let's get started. I'm going to write the model on the left and the equation on the right. I'll be using green to show positive values and red to show negative values. So I'm beginning by drawing in 3 vertical bars to represent the positive 3p. Now I'm adding 2 small red boxes to indicate the negative 2. I'll keep the equal sign in white, and now I'll draw on the model for the right hand side of the equation. There are 2 p's and they're both positives, so I'm using 2 vertical bars. There's 4 individual units, those are also positive, so I'll draw in 4 small green boxes. Now let's write the equation on the opposite side. 3p minus 2 is equal to 2p plus 4. Now my goal in this type of problem is to get the bars all by themselves on one side of the equation or the other. To do that, I'm going to start by eliminating the individual units. To rid myself of the 2 negative units on the left-hand side of the equation, to eliminate the 2 negative units on the left side of the equal sign, I'm going to add 2 positive units to both sides of my equation. When 2 negative units meet 2 positive units, they create 2 zero pairs. It's important to remember that when you combine 1 positive unit with 1 negative unit, you get 1 zero pair. So by adding 2 positives to each side of my equation, I've created 2 zero pairs on the left side. That will cancel out. Now I'll draw the results for both my model and my equation. On the left side, there are now only 3 vertical bars representing the 3 p's. On the right side, there are 2 vertical bars. And now there are a total of 6 positive units. Here's the equivalent for the equation. 3 p's are equal to 2p plus 6. Now I've redrawn the screen so I can continue on. The next step is to get all of the bars together on one side of the equation and all of the units together on the other. Since my units are already on the right side of the equation, I'm going to rid myself of the 2 bars that are also on the right side of the equation by adding the opposite. Just like you can add the opposite of a unit, you can also add the opposite of an unknown. But you must do the same to both sides of the equation. Here's what that looks like on the equation side. Subtract 2p, subtract 2p. On the right side, I've created 2 zero pairs, just like I have on the left side. 0 pairs cancel out, and I'm left with 1 bar equal to 6 units. Translating this into equation language, and we get p is equal to 6. Now, as I conclude the video, I realize that I've made, if not a mistake, I've done something that looks a little bit confusing. Right here, where I did the cancellation, only 2 of the 3 p's canceled. Since 3 minus 2 is equal to 1, 3p minus 2p is equal to 1p, or just p. Now this video isn't perfect, but if you feel as though you already understand how to appropriately write models and solve equations, then I want you to use this video and your prior knowledge to prove it to me. Bring me these 3 problems correctly modeled and correctly solved with the word lasagna written in big letters on the top of your paper. If you can do this correctly, I won't make you do the tiles tomorrow. But I will expect you to work independently so I can spend more time with the students who just don't quite get it yet.